in this video we're going to look at differentiating parametrically. And what do we mean by parametrically? Well, parametric equations are when we've got two variables defined in terms of some parameter t or s or whatever, but normally we have y as a function of x, but here we have y as a function of t and x is a function of t, right? And the reason I use t is because in my head this makes the most sense, easiest to understand when you consider the parameter of time. You might want to see how a variable y changes over time and how x changes over time, and you might want to compare these. So we could plot y in terms of x, but this doesn't really give us what we want in that sort of scenario. We want to see how they both compare to time, but then be able to see them against one another too. What we're looking at specifically in this video, and we will do more on parametric equations in general, but we're looking at, so we've got y as a function of t and x as a function of t, but how do we find dy by dx? Right? Because, you know, when we've got y as a function of x, we know what we have to do, which is differentiate with respect to x. But here, well, what's the trick? Well, we've got y as a function of t, so we actually take dy by dt, alright? And that's equal to, well, just f dash of t. And we'll have a look at some functions over here in a second. So we can do that pretty easily, and we can take dx by dt in the same way. Sorry, this is supposed to be g, and let's try that again. There you go. And to find dy by dx, we actually, this is equal to f dash of t over g dash of t. Alright? You take dy by dt over dx by dt, and you get dy over dx. Alright? So that's the rule to remember. Now we'll look at some functions. If we have y is equal to t squared minus 3 and x is equal to 1 over t, then differentiating y with respect to t, dy by dt is equal to 2t. You just bring this down and then subtract 1 from the power. The minus 3 just disappears, constants, the differentiator is 0, and then dx by dt, well, 1 over t is like t to the minus 1, so we apply the same rule. We multiply by the minus 1, and then we subtract 1 off the power, so we 1 off the power, and the power is minus 1, so we get a power of minus 2. Alright? So that's our result, and then doing dy by dt divided by dx by dt gives us dy by dx, and that's equal to 2d divided by minus 1 over t squared, so that is minus 2t cubed. So that was a pretty simple example, but I hope this does make sense. As I say, we'll do more on parametric. The reason I did this video now is I did my 20-minute differentiation video, and I think this was the one topic I might have missed out, so I will put this video in the link of that description, and yeah, and I'll also link that on this one too. But for now, I hope you enjoyed this video. If you did, your support would be much appreciated, so please like and subscribe, and I hope to see you in the next one.